Hey there and welcome back to the Code Wrinkles channel for a brand new video. In this one we'll talk about a topic that is or it seems to be very complicated, at least when you are at the beginning stages of the career. Not that it's really getting any easier, but you can get into more complexities afterwards, and this topic is async and await. And guys, I know that there are plenty of blogs or other videos that talk about async and await, but I think that actually I have investigated and I tried to understand exactly what are exactly the problems in understanding for most of the developers. And I think that I can bring something new or a new perspective, my take on async and await. So please keep on watching this video because you might find stuff that you don't find in other content out there. Good. Now, before we get started, I want to say that I have kind of like set up a little bit some very basic application, but before we actually go into that, I would like to, well, cook some breakfast. Let's imagine that we are in the morning and we just woke up and we want to cook some breakfast. Now, that breakfast would include, I guess, something like, okay, making also a coffee, but some fried eggs. I would maybe also have some bacon. And yeah, I guess that would be it mostly. But how do I actually do that? That's the question. And well, of course, when I try to actually do things, I basically go in the kitchen, I put all the ingredients in the coffee machine, then I start the coffee machine. And while the coffee is actually in the making, I start to heat up a pan. Maybe in the pan, then I put, when it's heated, of course, I put some eggs. And yeah, then maybe I also put some bacon, and when the coffee is ready, I take the coffee from the machine. And while I do this, and maybe while I also or already drink a little sip of my coffee, I wait also that the eggs and the bacon are ready. And maybe I just also, well, hook up the toaster and put a toast there. And yeah, while I drink still some more coffee, the eggs and bacons are finished, and also the toast is finished. And then actually I add some butter to that and maybe some jam, and that would be my breakfast. Here it is. Now, obviously, this sounds very familiar to everybody, but I guess this is actually a very good analogy to understand what are some problems with async and await, or what are some tasks or some challenges with synchronous code, because the way that computers are actually supposed to work is totally different than the way that our human brain actually works, and different in comparison to the way that we actually used to actually make the breakfast without too much thinking about that. But let's go here into this program, and well, let's just outline here a very first try on how we would actually get this done. And to make things easier, what I have already done here is I created a stopwatch, because we also want to actually measure in a certain way how long it takes for us to cook the breakfast when we do it programmatically. Then we calculate actually the seconds, and we just display here some messages. And I have already added some methods here, for instance, add coffee ingredients, that returns a void. And I have some internal classes, but that's only for a purpose to show you a little bit later in this video how tasks can return a certain result. So that's why I have added some classes for the coffee, for the eggs, for the bacon, and for the toast. Now I have a method here, for instance, for make coffee, and this method kind of like makes the coffee. And if we look a little bit into it, the only thing is that I have planted here a task delay. Now let's not get too much into what exactly this task delay is. I promise you we will understand this better till the end of this video, but right now it's important for me to actually understand that here in this place actually the execution of this method stops for 1 second in this case, and then the execution of this method actually resums. So that's actually what happens, and I have this kind of like task delay basically in all the methods here, except this method here, for instance, which is add butter to the toast, and this method here, which is the add jam to the toast. Now the first very important question, and really I want to emphasize this, is very important. Why in some cases I have actually added this task delay, like when I make the coffee, like heat the pan, or like fry the eggs or fry the bacon and make the toast. So all of those contain a task delay. But why this add butter to the toast or add jam to the toast, they don't have a task delay. And the important thing here is, and that's really the fundamental and the basics to understand what async and await is all about in .NET and generally. Now, the idea is that if I take a better look at this type of actions or processes, let's call them processes, what I can see, for instance, is that some of those processes are actually performed by myself. Like I am the one that actually adds butter to the toast. I am the one that actually adds jam to the toast. And of course, I'm also the one that adds the ingredients to the coffee machine. But on the other hand, making the coffee is not something that I do. It's a machine that does that. Then heating the pan, once again, it's not something that I do. It's something that happens externally to me. So it's not something that I can influence directly. It's not a direct action that I can take. Now, for the eggs and the bacon and the toast, it's exactly the same. The eggs and the bacon go in the pan, so they actually get fried there. So it's not, there's really nothing that I can do about that. And also making the toast, once again, I just put the bread in the toast and I kind of like wait for it to be ready. But I cannot really influence how fast the toast is ready. So that's once again something that it is really external to me. And this analogy is actually very important because this is really very similar to how the processors and how computer programs work. However, of course, in terms of, in more engineering terms, we can say that, okay, we have a process. Each application is a process. So it's when you start the application, it has a process. But then operating systems have also another very important thing, which is a thread. And a thread is the context of an execution for a certain calculation, because in the end, all that a processor does is a certain calculation. Now, within a process, you can have one single thread that kind of like does everything, or you can have different or several threads that kind of like do some stuff. And of course, you need a place or you need a way somehow to kind of like synchronize what each of that separate threads do. Now, the problem is that while threads actually are responsible, once again, to just perform some calculations, this is something that's actually internal to how the application works. It's there to actually perform some calculations. However, in our applications, we encounter a lot of scenarios where actually the application or the thread or the execution of the program waits for something that's external to the calculation itself. For instance, when we are reading from a file. Now, of course, the hard disk is way slower than the processor and then all the calculations that can take place in the processor. So this means that if my application at a certain point actually comes to a place where it needs to read a file, it kind of like stops there, because from that point on, it's something external to the calculation, to the processing itself. It just waits for the hard disk to actually deliver some information, and the hard disk could take some time. The same way that our coffee machine could take some time actually to deliver our coffee. Then at a certain point, your application might want to talk to a database. Once again, that goes over a network, and that's also, once again, very slow. And this means that this is also something external to the process itself, so external to the calculations that are being made. So when the application actually arrives there, it stops doing anything and it just waits for the network to actually give the information back from the database, which can take a while. Just the same way that we have to wait for the pan to get hot and then to put some eggs there and put some bacon and then wait for those to be fried. So it's exactly the same concept. Now, the idea is that what do I do when I do breakfast? Now, of course, while the coffee is done, I do something else. And while the eggs are fried, I maybe also switch on the toast. So I am actually able to not really stay there and wait the entire time until something happens, but instead I can focus on something else. Now, by default, computers can't do that. So by default, computers, when they arrive at that point where they wait for something external, they simply just stop. So that current thread that arrived at the spot just stops and waits. It doesn't do anything. It doesn't calculate. It just sits there and wait. So if we would be to simulate this kind of like behavior in our application right now, that would be what we call the synchronous application flow. And I have here prepared some code that we'll put here between the stopwatch.start and stopwatch.end. And well, that will kind of like do everything. Now, the thing is here, what happens is, and the way that usually the computer does this is add coffee ingredients. So this is something that I do that is pretty fast, so no problem there. But then make coffee, I have a task delay. So it means that when the program actually executes this method, it arrives at this line here, 33, and it just stops for 1 second. It doesn't calculate anything. It doesn't do anything. So that specific thread that is kind of like executing the code here in this method, when it gets here, it just stays there for 1 second without doing anything. And 1 second for a computer is really a huge time. Now, then of course, it gets further. Now hit the pen. Hit the pen. Once again, if we enlarge this method, we saw that we have also a task delay for 1 second. So it happens exactly the same. Now for the fried eggs, it happens exactly the same. So when it arrives here, there's this task delay here. It's 5 seconds. So it kind of like the execution stops right here. It doesn't go any further. It doesn't do anything. It just waits. It's totally idle. And yeah, of course, that also it goes the same way also for the fry bacon method, for the make toast method. And then finally, we have this add butter to the toast and add jam to the toast, which is something that I can do. So that is once again fairly fast. So that is kind of like the calculation itself. So the thread right now is doing something. It's not waiting. Now, the problem with this is that all these tasks here that kind of like, well, need to be done in order to cook the breakfast are performed sequentially. And if we run this application right now, for instance, yeah, let's run it that way. And we also have the stopwatch, and we can take a sneak peek into what actually happens here. Of course, first the application gets built. Now that should be already successful. And now we should start to see things. And here, okay, adding some ingredients, all ingredients added, starting coffee machine, and we wait. Coffee is ready. So we wait until the coffee is ready. Then hitting the pan, and then the pan is hot. So we wait until the pan is hot. We don't do anything else. Then fry 2 eggs, fry bacons, then add the butter to the toast and all the other stuff. So, but you can see here, actually everything is performed sequentially. And actually the sum of the execution time is the sum of the execution of all these methods and all those task delays, or kind of like the places where the application stopped just to wait for something. And just to make a comparison, it would be like you would cook your breakfast this way. But for instance, yeah, you say here, okay, I want to add ingredients to the coffee machine. So that's something that I can do. So that's pretty fast. But then starting the coffee machine. Now, when you start a coffee machine, you don't do anything else. You just sit there. You don't do anything else with all the other tasks for cooking the breakfast, but you are, for instance, if your phone rings, you don't answer it because you're waiting. You just wait there, so you don't answer your phone. If, I don't know, maybe somebody knocks on the door, you don't answer it. You don't do anything because you're waiting for the coffee machine. Now, when the coffee is ready, you go to the next task, and once again, it's the same. Like, no matter what happens around you, you just wait there. So you don't do really anything else in that time. So it's exactly what happens with the processor when we kind of like have these long-running tasks, or long-running work that actually has to do, or usually is connected to some external sources or external resources compared to the processor itself, where all this code gets executed. And of course, this kind of like brings 2 problems, and we'll see how we can actually solve these problems. And we'll also look into a misconception about async and await, because the first problem that we have here is that we are kind of blocked. So when we start a certain task, we are blocked. We are really not able to do anything else besides that task. And that is a huge problem for desktop applications, where you by default have a UI thread, and you have then a backend thread for your background logic. It means that while your background thread or your backend logic is actually performing, it means that your UI is not responsive at all. So it kind of like freezes, and that's it. And that's really, really bad. In web application, it's not that bad because you can see this problem, let's say, right away like you do in desktop application. But there is also a problem with the web applications, because each web server has a certain number of threads that is allocated for the specific web server. And let's assume, for instance, that I don't know, that the current server has only a pool of 3 threads. Now a request comes in, then it hits such a task that, I don't know, it needs to wait for 10 seconds. Then that specific thread actually stays there and waits for those 10 seconds. Now, let's assume another request comes in right away. Then the second thread will actually, take that request and do the logic. But once again, it will stop and just wait for 10 seconds. Now, a third request comes right in and it happens the same. Now, if a fourth request comes in, then you're suddenly out of threads. So your server doesn't have any thread that can actually take care of that certain request, and that is a real big problem. Of course, usually or most often you don't really see this because you have to actually have a very high traffic that kind of like goes over or above the number of threads that your web server allocates for your application, but this could definitely happen. So that's also a problem for web applications. So this is the first problem, that threads get blocked and they just wait there and they just get exhausted, so you don't have threads anymore. So that's a big problem. Now, the second problem that we have with this approach is that kind of like we said, okay, when we cook breakfast, we kind of like, okay, we start the coffee, but in the meantime, or while the coffee actually is made, we already start to do something else. So kind of like we run those tasks in parallel. Now, here in this case, our CPU, our computer runs this task sequentially. So that's the second problem. So we'll see how or if we can get to also run this in parallel. But once again, here there is also a misconception, but we'll go into that async and await kind of like also solves the problem with the parallel execution of tasks. Cool. Now, let's go here to the next application, which is this breakfast async basic. And what we have in this breakfast async basic, we'll just also take these methods from here, and we'll go back here, and let's just make sure that they are all correct, because I have already prepared this in advance. So that's exactly the code that we had previously. So that's exactly the code that we have in the previous application. Now, the way that we have the exact same code, because I want to actually right now go into the detail. Okay, how can we actually implement asynchrony in C# using async and await? Because async and await is here to actually help us solve at least one problem. And the problem that is solved certainly is the problem with the threads that kind of like get blocked. Because when you're using async and await, what happens is that when the application actually arrives at a point where you await something that you mark with the await keyword, actually that thread is not blocked anymore because it is released back to the thread pool. And only when the result from the external resource is available, then we get kind of like a new thread that would resume execution from that point. But in that meantime, in those seconds where actually the thread would not do anything, is instead of just sitting there and wait, it is released and can be actually used to perform some other work in the meantime. So that's kind of like the concept of async and await. Now let's change all these methods here to actually reflect this idea of async and await. Now, the add coffee ingredients is not something that we want to make async, because that's something that we do, so we don't rely on some external resource for that. But then we have this static coffee, so returns a coffee and make coffee. Now, if you want to actually use async in await in C#, in .NET, there are actually a few things that you have to be careful about. The first thing is you need to mark this method as async with the async keyword. Now, the next very important thing is that async methods should always return a task. And in this case, it's a generic task, which is a task of coffee, because in the end, we just want to have a coffee. And here, instead of having this wait, so that we make sure that we wait, we just set the await keyword. That's it. And then the other very important thing, which is not mandatory, so you can compile the code and run it, but it is a best practice. When you have async methods, you need to actually also add the async suffix here. So right now we have actually well, switch this method from a synchronous one to be an asynchronous method. So async keyword, it returns a task, and then await when we actually have to perform that work that's external to our application flow itself. So when we just have to wait here for 1 second and use the async suffix in the end. Now, the thing is, what's actually this task about? Well, I guess the word task actually here in .NET is a very good choice from the naming, because from the beginning on, we said that, okay, we want to cook some breakfast and hey, we have some tasks that we actually want to do. A task is nothing else that, well, as the name implies, a task that you kind of like give to somebody, and it just promises you that when the task is completed, you will get a coffee back. So that's the whole idea of a task. You just assign the task, somebody will perform something, and it kind of like ensures you that at a certain point when the task is completed, you will get your coffee. So that's very important. However, we have, of course, also methods like this heat pan. Now, of course, that's void. We cannot use void. So once again, we want to make this async. So it will return async task. Now, the only thing is that here right now, hey, we just want to, well, hit the pen. We don't really want to return anything. So in this case, it's not a generic task, but it's just a regular task. Now, that's very important because always, or there are a lot of cases or well, code samples that I have seen where I have seen something like async void. Which theoretically is no problem. You can do that, and we can actually try to actually implement that. So the compiler really won't complain about it. It would actually let you do that. However, there are a lot of problems with the async voids because that kind of like short circuits the synchronization context, and a lot of things can go wrong. So, well, as a rule of thumb, never actually have an async void method. Instead, if it just doesn't return anything at the end, you just use a regular task class. So not a generic task, but a regular task. So you just return a task. Cool. And then you do the job. Now, the same thing here is for the eggs, but here we'll have to, we'll need the async, and here we have this task of eggs. And then we have to replace here this one and place the await keyword here, and here there's another async, and that would be a task of bacon. And here we'll just have to also take this wait out and use the await keyword, because that's actually the setup that guarantees us actually this asynchrony in .NET Core. Then make toast. That's the same way, async task. It returns us a toast. In this case, actually, that's very important because we need the toast to pass into actually to the next methods where we add the butter and the jam. But of course, I said, and I forgot this, we should also add the async suffix to these methods because right now they are async. And yeah, once again, fry bacon async, heat pan, make toast async. Here we also need to change this wait and use the await keyword. And right now we have actually changed all our methods are right now asynchronous methods because they are using this async and await, and they always return a task. So we are good to go. Now let's go back here and say, okay, how we should perform things here. Now add coffee ingredients, that's not an async method. But then here we have this coffee, make coffee, and we want to get the coffee. So we want to have the cup of coffee. So what we'll do here is we'll just say make coffee async, also with the wait. Then here we want to wait for the pan to get heated because otherwise we cannot fry our eggs. And the eggs, once again, we can await and fry eggs async. And await, fry bacon async. And last but not least, here we have await, make toast async. And right now we should actually be good to go with our application. So if we, let's just debug this one. So let's go on debug and let's just wait to see. Okay, it gets built, and let's see what happens here. So the application is here and we should be starting right now to actually receive some results here. So yeah, the application runs. So okay, adding ingredients, all ingredients added, starting the coffee is ready, heating the pan is hot, frying the eggs, then eggs are ready, frying 2 slices of bacon, and here we still wait again, we wait and bacon is ready, then we prepare the toast, and then yeah, we want to actually add butter and jam, and it took us also 17 seconds. And if you remember from the previous execution, it also took us 17 seconds. So here is where you can see in action that actually a lot of people might think that, hey, if I'm using async and await, kind of like those asynchronous methods are executed in parallel. But that's not true. So a plain async and await, it actually only solves the problem of blocking the threads. And in this case, if you use async and await, the threads will not be blocked anymore. So when the execution arrives at a task delay and it just needs to wait, then that thread is released back to the thread pool and can be used by another application or by the same application to perform some other task, while this one is actually waiting for an external resource. And that kind of like helps us a lot, because in desktop applications, only by using correctly async and await just helps us to not have an unresponsive UI. And in web applications, as we discussed earlier, if you have everything with async and await, it will kind of like ensure you that it's very, very hard to actually get out of threads, and that, your request cannot be serviced anymore. So that kind of like solves a lot of problems, but not the problem of running tasks in parallel, which is a totally different thing. Of course, when we have this kind of like await, if we want to get the result back, we kind of like need to await something. Now, if we don't really need the result back, like here the toast we need necessarily because we have to pass it as a parameter to the other methods, but here the coffee, okay, we just have it, but kind of like, okay, we don't do anything with that. And we could say, for instance, okay, in this case, I will not want to await that coffee. And in this case, I just say make coffee async. Now, what will this do is that kind of like, okay, let's run this again. And we'll see that kind of like right now, the coffee starts, but then before it actually ends, we start to do something else. Like for instance, you see here that starting with the coffee machine, instead of waiting until the coffee machine is ready with the coffee, we see here heading the pan, and then at a certain point we see here coffee is ready. So kind of like that ensured us that our execution time is 1 second less. So kind of like there is a little bit optimization. However, the problem is here, theoretically, if we have this order of tasks, and if we look into those and we know exactly how much time each task actually takes, we can kind of like reorder them in a way that would optimize our output. However, the problem is that if kind of like this changes, because in real applications, you never know how long it takes for the database to respond, or well, how long it takes for a HTTP client to get a response from a web server. Now, the idea is that you cannot really try to optimize by, okay, awaiting certain tasks that you know that take longer and not awaiting other tasks that you know that, well, they might not take that long. So that's not an option, because at a certain point, if those values change, or the ranges of those values change, you certainly see that, hey, okay, you have started 3 tasks, but kind of like the execution of the method ended before completing all the tasks. So that is really a big problem. So you cannot simply just optimize or think that you might parallelize in a way by the fact that you await some methods, but you don't await other methods. So that's really important. That's, once again, a total misconception. If you're using async and await, it kind of like solves the problem with blocking the threads, but it really doesn't solve the problem of executing tasks in parallel. Now, to solve this problem, let's go to the next application and take a look at how we could do that. Okay, so here's the third application, which is breakfast, or cooking breakfast, but in a parallel way. And here, once again, we have exactly the same code that we had in the previous one. And we want to see how we can refactor this to kind of like also implement this concept of running tasks in parallel. Now, the first thing that we actually need to do as a step is take a better look at our tasks and try to find out in a certain way which of the tasks in a certain way belong together. Because here, for instance, add coffee ingredients and make a coffee async, that they kind of like are the same action. Now, of course, there's a part that is synchronous, like adding the ingredients, and there's a part that's asynchronous. But well, they kind of like belong together. And here I want to go into this topic about how we can compose actually asynchronous methods that contain actually some parts that are not asynchronous, but some parts that are asynchronous. So what we can do here is we can go to this make coffee async, and actually instead of having this add coffee ingredients that run separately, we can just actually start by doing or invoking this method here. So add coffee ingredients, and then that is not awaitable because it's not something that's async. Then it kind of like executes everything that's in here, and then it executes this, and we have this async and we have this await. And what we can do here is instead of having this add coffee ingredients, we don't have it anymore, and we have just the coffee. Now, the same thing if we think about this heating the pan and the eggs and the bacon, they kind of like belong together because both the eggs and the bacon are fried in the same pan. So instead of having everything here, we can, for instance, go to this, where is it? Not make toast, heat the pan. Let's maybe just create a totally new method that kind of like would compose all of them. And yeah, let's just go here and start here static, and we know that it's an async, and yeah, in this case we just return a simple task, and we'll call this pan frying. Like here is what we want to fry in the pan. Now this one will have actually 2 or 3 parts: await, heat pan async, then we'll have await fry eggs async, and then we'll have here await fry bacon async. So we'll await also that, and yeah, then this task's complete. So then we can go back here, and instead of having here these 3 methods, we can just have here maybe like an await, and we kind of like used this method here. Now the last thing that we could do here is for the toast, and for the toast, once again, if we take a look at what we want to do here is we have a make toast async, then we have this add butter to toast and add jam to the toast. That's something that should happen afterwards, but they kind of like belong together because it's still making the toast. So what we'll do here is we'll add butter to the toast in the same method, and we'll pass in the toast, of course. But yeah, that's wait for, we just have to assign this to a variable. Sorry, not here, not this task delay. That's that's what is delayed, but we can just well have this new toast var toast equals new toast, and then we can simply just move this afterwards, and it theoretically should be just fine. So okay, we add the butter to the toast and we add the jam to the toast. Cool, we have a toast, and then we can return this right now because it's ready. It's toasted, it has butter, it has jam, and it's kind of like ready. Cool. So if we go back right now here, instead of having these things here, we can simply have here, for instance, await, and you can say here make toast async, and that kind of like should do everything that we have here. Cool. So now actually we have we are a step forward because we have moved kind of like parts of the process that belong together into their corresponding methods. And of course, everything is executed asynchronously. So if we run the application, we see that it should actually perform the same. However, the fact that we have refactored this, once again, it will not make our application run in parallel, or the task or the processes run in parallel. They still will run sequentially. However, we have right now, we know better right now how we can actually compose async methods that contain parts that are asynchronous and that contain parts that are not asynchronous. So that's what we have done. And we still that, okay, we still have these 17 seconds. Okay. Now, how can we actually make this run in parallel and make sure that kind of like we wait for all the tasks to finish until or before we stop the stopwatch, and then before we print this kind of stuff in the console? Now, the important thing here about, or the important thing to note here is that as you see, these methods that kind of like they return a task of something or a task. So they return a certain type. So right now, okay, we just invoke them with await and kind of like we await for something to be done, but we can actually use here variables, and we can use these variables, for instance, var. But here we don't need this hit pen anymore. Sorry for that. That's not something that we need. But for this coffee, var coffee, you see that it's let's rename this to coffee task. Because that's a task. You see that it's task of something, okay? And then here we'll do exactly the same thing and say here var pan frying task equals, and that's the task. So that's actually the task. Cool. And we'll do the same thing with var toast task. Now the thing is that when we actually do this, those tasks will also be executed, and it means that the execution will start. However, we just fire them here, and theoretically, well, each task will, well, then start to actually be performed, so we don't await for it to be ready. But we want a way to make sure that all the tasks are running parallel. So without the wait, we are sure that all of those will actually run in parallel. But the thing is that right now we don't control actually what happens. And let me maybe just debug this application, because I guess that would be the best way to actually understand what happens. Because right now in the console, you will say that we have actually, well, the starting part of all of them, and then it took you 0 seconds. Because we just got everything started, and yeah, we didn't wait for the tasks to finish. We just started them, and yeah, all the tasks waited, and then well, we just went forward to actually run this part of code here, and we want to avoid that. Now, the cool thing about this task, and that's why this task class is very important when we talk about async and await, because the task class itself, it has some features that helps us to kind of like better manage asynchronicity or asynchrony or parallelism within, well, the code that we are writing with async and await. And for instance, we can say here await task, and let's take a look here. We have a completed task, which is a method that kind of like sets the task on completed. We have the delay, so we can delay the execution, like we have done actually in those methods to simulate that kind of like the execution stops. We have also a factory to actually create a new tasks. We have this when all, when any, and there are a bunch of other methods that we have kind of like on this task class, which are very, very important. Now, if we want to make sure that we wait for the execution of all the tasks, we can say here when all, and in the when all, it takes in a params, so we can give as parameters as many tasks as we want. You can create maybe a list of tasks and then place the list there. But what I will give here is, first of all, coffee task, then pan frying task, and last but not least, I will give here the toast task. Now, what this actually does, it kind of like we fire the task, so they kind of like start to execute probably in parallel. But then instead of going forward with the execution, we just say, hey, okay, we just want to wait until all the tasks are finished. And only when all the tasks are finished, we want to actually go further with the application. And if we debug the application now, we should see definitely some improvements when it comes to the execution time, or how much it actually did take for us to get all the breakfast done. Here we have this jam added on the toast, and the frying, and the slices of bacon, and yeah, now also the bacon should be kind of like ready just in a few seconds. And we see that, hey, we have here 14 seconds, which is kind of like very, very nice. So from 17 seconds, we are down to 14 seconds. And that is actually very, very good, not bad. But can we do even better? And if we look in our code, okay, where is a part where we are still waiting on a lot of tasks? And if we scroll through here, we see that, hey, we have just a task delay here, another task delay here. So it's not really a big part, but we have created this composition actually, this task composition or async tasks composition inside this method, because we have an async method, and here we await heat to have this ready, we await this, and then we await this. So there is actually the same way that we did here with when all. It's something similar that we can actually do here with all those other tasks. So here, instead of, where is that? So instead of, we definitely need to await for the pan to be heated, because if the pan is not heated, then we cannot fry the eggs and things like that. But then we have here, for instance, var frying eggs task equals, and we can see simply like that, like it was previously. And we can say here, we don't use this await, and we have here var, and here frying bacon task, and that's equal with that method. And then we can do here tasks when all, and here we just provide those two tasks, so frying eggs tasks and frying the bacon tasks. And right now, and of course we need to await this, because otherwise nothing really will happen. And here, if we debug once again, we will see that theoretically we should have optimized the execution type of our breakfast cooking even further, because right now actually frying the eggs and frying the ham will kind of like start together. We'll just put them actually in the same pan, and we see that here we have, instead of 14 seconds right now, we are back to 9 seconds. So we kind of like optimized, we need half the time that we actually needed before we did any of the improvements, because really the first run with the totally synchronous flow, it took 17 seconds, and from 17 seconds we are right now back to 9 seconds, which is very, very nice. But once again, guys, it's important that async and await alone doesn't really solve the problem of running tasks in parallel. If you want to run tasks in parallel, then you just have to execute the task, make them running, fire them. However, don't forget them if you are counting on the result, or if it's important for you to actually perform an action when all the task is completed. And instead of, well, just hoping that everything will get well or go well, just use this task and when all. And this will kind of like synchronize the execution of all your tasks. And when all your tasks are completed, then we can go on and do other stuff that we need. So this is the way that we kind of like implement this idea or this concept of parallelism with async and await. Cool. So I guess that's pretty much what I wanted to show you or talk about you regarding async and await. And before we wrap up, or before we finish this video, I want to once again emphasize the very important conclusion. And the conclusion is that when we have synchronous code that kind of like depends on external resources like databases, files, or other things, so that where actually threads or the execution of the program just stops and waits for something to happen, it doesn't do anything. That's a big problem. And the other problem we have is, or that we might have with how long it takes to perform something, is if we are able to kind of like parallelize, I don't know how exactly to pronounce that, the tasks. So not to wait sequentially, but kind of like run them in parallel and just wait until all are done, and then kind of like do something else based on what happened with those tasks. Now, once again, async and await just solves one problem alone, the problem with the blocking execution or the blocking threads. So when you use async and await, the way that we actually do here in this one it kind of like helps us to make sure that when the execution of a program hits something where it just has to wait, that thread is not blocked. It is immediately released, so it can be reused for something else. And when the time or when the data is ready from the external resource, then another or the same thread will be assigned here and will resume the execution from where it stopped. So async and await solves this. And that's important to know, because simply by adding async and await, it doesn't mean that you actually run that the execution time of your application or of your code is faster. It just means that it doesn't block the threads. If you want to make sure that the execution, especially if you have different tasks, and if you want to make sure that the execution is faster, you need a way to actually look into how you can parallelize tasks. And the way or the optimal way to actually do this in .NET is by simply firing the tasks and then using this task and then when all to wait for the tasks that you are interested in and then perform and then execute the code further, and everything should work fine. Guys, I know this video got very, very long, but I hope it was interesting for you, and I hope that the explanations that I try to give here help you to better understand exactly how async and work works in .NET. And if you think that other people might benefit from this content, don't be shy and share it with your peers, with your friends, in your social networks, or even forums, wherever you might see fit, or wherever you think that there would be people that might find this useful. Just share them and they will be thankful to you, and I will be, of course, thankful to you as well. But more than that, if you have any questions or if you just want to say something, hit the comment section and leave a comment, and I will be more than happy to get a discussion with you. And I try to really answer all the comments that I get. Last but not least, if you haven't subscribed to this channel already, please do subscribe and hit the thumbs up button for this video. That would help us a lot, and that would be highly appreciated, and I would be eternally grateful for that. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.